The last method that we're going to look at for solving systems of equations and linear equations in our case is called elimination. The key with elimination is that your variables are aligned. So the x's need to be aligned with one another. The y's, your equal sign is equally as important, and your constants. If you notice, these are in standard form. Standard form is probably the easiest setup in order to do elimination. The second key is that one of the variables, coefficients, are the opposite of one another. So if we look at x's variables, they're close, but they both happen to be 3. If we look at y's variables, however, they are opposites, 2 and -2. So the y values can be easily eliminated. So we're going to add together column by column each set of terms. So I'm going to add together the 3x's to get 6x. When I add together 2y and -2y, it is 0. So they are essentially eliminated. That is equal to 4 plus -4 is also 0, but I can't leave a side blank, so I have to fill in 0. Once I divide out by 6, I already get my first coordinate, or x value, within the coordinate of 0. However, I am not done because I need to find the y coordinate. When we are finding the second value, it doesn't matter which equation you go into. You can plug 0 in for the top equation, or you can plug it in for the bottom equation, and you'll still get the same answer. So 0 times anything is 0. So it's like it's not there. Once I divide out by 2, I get that y's value is 2. Same thing, once I divide out by -2, I get y's values 2. I just showed it 2 different ways. So that means if I were to graph both of these equations onto the coordinate plane, it would cross at 0, 2. This coordinate still represents the point of intersection for the line. For example number 2, if I look at my x coefficients and my y coefficients, unfortunately, neither set are opposites. So what we're going to have to do is we're going to have to use a multiplier. And it really is just a preference for if you want to multiply to eliminate the x's or if you want to multiply to eliminate the y's. So since 3 and 6 are already opposite, as in positive, negative, I'm going to choose to eliminate my y's. So the opposite of -6 is +6. So that means in order to get my y value to be 6, I need to multiply every single term in equation number 1 by 2. So I end up with -20x plus 6y is equal to 2. I like to rewrite my second equation underneath just to keep my work organized. So equation number 2 is -5x minus 6y equals 23. Now that I have opposite values that can be eliminated, I'm going to add my columns together. So -20x plus -5x is -25x. My y's were eliminated. 2 plus 23 is 25. Once I divide out by -25, I get that the x value is -1. Now I have 3 options that I can plug into. I can plug into equation number 1. I can plug into equation number 2, or I could even plug into my multiplied equation. I'll get the same answer no matter what. So I'm just going to plug into equation number 1 just to choose something. So I know x is now worth negative 1. So I have negative 10 times negative 1 plus 3y is equal to 1. Then I simplify. Subtract my 10 and divide by 3. So my final coordinate is negative 1, negative 3. Once again, this represents where our two linear equations cross on the graph. Looking at example number 3, I don't have an easy elimination. My x values aren't the same. My y coefficients, aren't opposites. So since we've eliminated y on the last two examples, I'm going to go ahead and eliminate x this time. So the opposite of negative 4 is positive 4. So I'm going to multiply my entire top row by negative 2. That way, when I multiply by negative 2x, I end up with positive 4x, negative 2y, and negative 6. So once again, I'm going to reorganize my work by writing equation number 2 underneath. And I'm going to add my columns together. Now, this is going to end up being a special case because what's going to happen when I add 4 and negative 4, my variables get canceled. When I add negative 2y and positive 2y, my y variable gets canceled. When I add negative 6 and positive 6 together, my constants also get canceled. I can't have blank sides though. So the right-hand side and the left-hand side are both going to be 0. Is 0 equal to 0? Yes, this is a true statement. Therefore, my answer is all real numbers or infinitely many solutions, because I am dealing with the same exact line on a graph. In our final example, our first equation is written in slope-intercept form. Our second equation is written in standard form. So before I even start, I want to rewrite equation number 1 in standard form. So I'm going to bring the negative 10x out in front. So I have 10x plus y is equal to 2. This is just my equation number 1 rewritten. I don't have opposites. I have close to opposites with both of my variables. So in order to create opposites, I'm going to multiply equation number 2 by negative 1. So I'm left with negative 10x, negative 1y is equal to negative 10, making sure that I multiply every single term. And then I'm just going to rewrite equation number 1 again. 10x plus y is equal to 2. I'm going to add my columns together. Negative 10 and positive 10x, eliminated. Negative y, positive y, eliminated. I can't have a blank side though, so I'm going to put the value of 0. The right-hand side does not get eliminated. Negative 10 plus 2 is negative 8. This creates a false statement because 0 is not equal to negative 8. Therefore, our answer is no solution. If I were to graph these two lines on a coordinate plane, the result would be two parallel lines.